Hi everyone, thanks for joining us for the session today. I'm your host, Mala Gupta. Today I'm pleased to welcome Johan Voss, Java champion, author, co-founder Gluon, co-lead for OpenJFX, international speaker, conference organizer, and much more. Hi Johan, it's a pleasure to have you present today.
Hi, thanks for having me.
Johan will talk about JavaFX. What is it and why you need it? Its structure, components, the roadmap of the OpenJFX project. He'll also cover and demonstrate how you can use JavaFX for development of UI in Java on desktop, mobile, and embedded clients. Before I let Johan take the stage, let me share some quick housekeeping details. Please use the YouTube chat to post your questions. I, Anna Kozlova, and Trisha G from the JetBrains team will answer your questions as you post them. Johan will take quick breaks while presenting to you to answer your questions, so you don't really have to wait until the end of the presentation to ask them. And the session will be recorded and hosted to IntelliJ Ideas YouTube channel. So Johan, I'll let you take the stage now.
Thank you very much, Mara, for the nice introduction. And welcome all to the session about cross-platform UI development in Java. Some quick words about me. I've been working with Java since 1995 as part of the Blackdown team porting Java to Linux. I'm the co-lead of the OpenJFX project where JavaFX is being developed and implemented. I'm also the lead of the OpenJDK mobile project. I'm a Java champion and author of the JavaFX book that you can see on the screen there. I'm the co-founder of Gluon, JavaFX company by and for Java developers. I have a PhD in physics, and I'm also author of a quantum computing book for Java upcoming. Quickly about Gluon, the company that I co-founded a couple of years ago. We are sort of the JavaFX steward, so we contribute heavily to the JavaFX platform. We drive it forward, we make the distributions and do the maintenance releases and the long-term support releases. We invest heavily in open source, for example, OpenGFX, but also the ecosystem around it, the plugins for Maven and Gradle. We are the maintainer and distributor of Gluon Scene Builder, and we have a bunch of other open source projects. Our main products are Gluon Mobile, which enables you to make applications in Java and run them on mobile devices in a very shiny way and with all the tools that you would expect from mobile devices. And Gluon Cloud Link that allows you to connect mobile, desktop, embedded applications to the cloud. We provide commercial support for JavaFX 11 long-term support releases for companies that want stability. And we do project and consulting, and you can find more information on Twitter or on the website. So what will we cover today? So first of all, I will give a brief introduction in what actually is JavaFX. Then I will show some code on how you can use JavaFX in IntelliJ IDE. Then we will talk a bit about the JavaFX ecosystem and how the JavaFX specification and everything around it is being developed. And finally, we'll go into a little bit detail on how JavaFX is structured, how it achieves this, what is its architecture, and what are the most important future plans, at least the ones that we know currently. So first of all, what is JavaFX? And it's difficult to come up with a unique definition of JavaFX. So this is just my personal definition. JavaFX contains the Java APIs for the client development in general and for UI development in particular as part of the Java platform. It is developed under the OpenJDK umbrella in a project called OpenJFX. It is part of the OpenJDK umbrella, but it is not part of the OpenJDK project. And there we go already with some of the confusion. But I hope that by saying this before I start the presentation, that it is clear that we are part of the OpenJDK, let's call it foundation, but the JavaFX code itself is not integrated in the Java code base. We use the JavaFX namespace, so the packages that you use as a JavaFX developer are JavaFX application, JavaFX scene, and so on. And it is more or less the successor of AWT Swing, which were the first UI toolkits in Java. And JavaFX is a modern graphical toolkit, and it combines hardware acceleration, which was not very widely available in the first days of Java when AWT and Swing were created. But now GPUs are everywhere, so JavaFX takes advantage of that, but also takes advantage of the typical Java characteristics like security, maturity, performance, and of course the large ecosystem. So the JavaFX stack that we typically imagine for a JavaFX application is that you have a JavaFX application on top of some libraries. Can be open source or commercial libraries, and those are built on top of the JavaFX platform, which is then integrating with the hardware underneath that platform to deliver the highly optimized and high performant rendering. So that is more or less the typical stack. What are the components then in that stack? So at the top, we have the user interface components, the layout containers, the controls, and so. And these are the foundation for developers, application developers, or library developers, sorry, for create their libraries, framework, applications. They use the Java APIs. For example, they can programmatically declare a button with the classical Java style. They can also use Fxml if they want to declaratively declare a user interface, and typically developers are using Scene Builder for this. We will talk about Scene Builder, and I will show Scene Builder later in this presentation. And finally, they typically use CSS to style the components. So CSS is a technology that we sort of inherit from, well, it's very often used in web design, and it is actually also applicable to Java, and you can style different components the same way that you would style web components. What is the relation between JavaFX and Java? This is food for lots of discussion, and especially lots of confusion. And as I said already, JavaFX, OpenJDK, and OpenGFX are two separate projects, but they are under the same umbrella, which means that we share some of the infrastructure, we share the Jira issue tracker, we share most of the policies and the structure about the different roles between author, committer, contributor, reviewer, project lead. So that's all shared between OpenJDK and OpenGFX, but the code base is completely separate. And as most of you probably know, there was a time that the Oracle JDK contained the JavaFX jar in its distribution. And it was in the X folder, there was a file named jfxrt.jar that contained JavaFX. But that was a bit an awkward solution because not everyone needs JavaFX, and also it coupled JavaFX very tightly to Java. And what we have today is, in my opinion, much more flexible. JavaFX has its own set of modules, and you can decide to bundle them with your application, or you can create your own GRE, or they can be bundled in an SDK. So by default, you should not assume that the Java SDK that you're using has the JavaFX modules. But the JavaFX platform assumes that it is loaded via a module. So the JavaFX graphics module should be part of your runtime somehow. And therefore, we created a plugin for Maven and a plugin for Gradle that takes away the hassle for configuring the module path when you're writing JavaFX applications. We created a website, OpenJFX.io, where this is explained and where clean samples are available for developing using Maven or Gradle or any IDE. So before I switch to an IDE, I will show the typical hello world application in JavaFX, just to make sure that you can see that this is a Java application like any other Java application. So we have we import the packages, the JavaFX classes that I talked about before, JavaFX application, JavaFX scene, and so. And our class HelloFX extends the JavaFX application, and it overrides the start method. This method is called when the JavaFX runtime starts our application. And as a consequence, we are also provided with a stage object, which is the root object of our JavaFX application. And then we can do many things with that stage object. We mainly construct a scene, and we assign different UI elements and layout controls and so to that scene, and then we display the scene. And the result of this application is what you see in the right part of this slide. So how can you use JavaFX in IntelliJ? Let me switch to IntelliJ, and let me start with, actually what I'm going to show now is also what you can find on OpenJFX.io. But I'll start with a fresh application. We create a new application, a new project, and we will start from an archetype, because that's actually the easiest way. I already have this archetype in my list. In case you don't have it, you can add archetype. It's org.openjfx, and you can find this information on openjfx.io. But I already have it here. It's a OpenJFX JavaFX Maven archetype 005. We give this a name, for example, IntelliJ demo. And we can now tune some of the parameters. The one that we need to tune here is, let me see, the archetype artifact ID. We have two archetypes that are supported by this archetype plugin, and the simple one is JavaFX archetype. That's simple, so that's the one that we want to have. And maybe we also want to specify the JavaFX version. We want to have the latest version, 15.01. There we go. And now the project is being created, and you should see that immediately. Meanwhile, let me see if there are questions. Okay. So the project is created, and as you can see, we have a POM file now that contains the information that we actually supplied in the artifact ID. So we can see here that we're using the JavaFX controls module, and we are using the JavaFX Maven plugin 004. We're actually at 005, but that's okay. And our main class is the org example app. So this is created for us by the artifact ID, by the artifact archetype, sorry. And that's just the POM file. We are, of course, interested in the application that's created. So a demo application called app is created, and this looks very similar to what we saw in the on the slide. So this is a simple application with a start method, and it will show the stage that we were given, and it will render a scene that contains a stack pane, which is one of the layout containers, which contains a label, which is one of the JavaFX controls, which contain a text and the version of Java and JavaFX. Now, if we want to run this, remember that this is a Maven archetype. So we go to the Maven tool window, and then you can see on the application that we just created that we have in the plugin, we have here a JavaFX extension, and there's a JavaFX run task. And that is actually how the application is started. So if we run this Maven build, so that is actually the run command should be mapped to this Maven run command. And then the application is shown in a separate window, which hopefully you can see on the stream. So this is showing JavaFX 15.01 because that is actually the version that we were using, and it's running on. Well, yeah, I'm using an older Java version here, but that is how the hello world of JavaFX is being created, built, and executed. So if you follow these procedures, if you follow the recommendations, it's actually easy. I do realize that most of the questions about well, issues with JavaFX that we have is that if you're trying to run JavaFX application not on the with the JavaFX modules, not on the module path, but on the class path, it might work, but it also might not work. So therefore, I cannot stress this enough. If it's highly recommended to use the plugins that will configure the module path and the class path for you. So you don't need to do anything else. You don't need to install a JavaFX SDK. And so if you're using the Maven archetype, everything is taken care of for you. Let me quickly go back to the code here, and let's just add something. Oh yeah, the template is using the var here. I'm old-fashioned and not used to it yet. So let's create a button, a JavaFX button where we have click me, for example. And so this is another JavaFX control that I quickly add now. And I don't want to give a course in JavaFX in this short session, but just to give an idea about how JavaFX development typically goes. There are lots of single abstract method classes in JavaFX, which were created before Lambda expressions were a thing, but which were very easily converted into Lambda expressions. For example, if this button is clicked, we can invoke the setOnAction handler, which we can then use to, for example, let's set text, change the text on this label that we created. So if this button is now clicked, the text in the label will be changed. Let's now also, instead of the stack pane, let's create a VBox where we can vertically stack different components. It's going to be ugly because we're not styling it nice. The only thing that I want to show now is how you can easily add a control in JavaFX and add it to the stage. And is that still running? So let's restart the application now, and it should be up immediately. So as expected, we now have the ugly vertical box completely unstyled, but we have a click me button under the label. And if we click it, you see that the text changes in click me. So that is very briefly how you can create a JavaFX application using IntelliJ and using the artifacts. And it's very, very small. But it's I think it's good to start this way. Let me see if there are questions that need answering now. Mala, do we have questions that you think should be answered?
Johan, no, I think you can proceed because, as I mentioned, Anna and Trisha are already answering the questions, so there are no showstoppers as of now.
Great, thanks. So that was the hello world. That was ugly, and it's I'm not doing a favor to JavaFX by showing my UI skills. I really have no design skills, and so, but I can. I'm fortunate enough to know some great projects. For example, this is a deep space trajectory explorer created by AI Solutions. It's being used by NASA to visualize orbits around Moon, Earth, or in any kind of orbits. And this uses lots of computations and visualizations that need to be updated very often and very fast. So this really stresses the system that it is running on, and there the hardware accelerated rendering of JavaFX is really key. So this, I think, everyone will agree that this is slightly more impressive than the Hello World application that I showed, but it is the same language. So you should be able to do to create this as well. This is a medical software created by Carl Zeiss or used by Carl Zeiss. Also using JavaFX different components. So this gives you an idea about what you can ultimately do with JavaFX. So just to convince you that it doesn't stop at Hello World or Hello FX, but it's just the same ideas. It's also important to stress that you're not limited to desktop alone. So what you see here are two screenshots, one from an embedded device on a Raspberry Pi with a touchscreen running a Mary Had a Little Lamb application from Stephen Chin. And the right one is a screenshot from an iPhone, I think, running the DevOps conference scheduler, which is also written in JavaFX. So if you write your JavaFX application in Java, it runs on desktop, but also mobile and embedded. And I'll come back to that later, because there's often a question, how comes you can run on iOS? Because it's not allowed to have a Java virtual machine. We'll answer that question near the end. Or a telematics application with maps. This runs with a very high frame rate. So that is also telematics and embedded and edge devices are really very good areas for JavaFX because of the hardware accelerated rendering. Okay, so let's talk a bit now about the JavaFX ecosystem and the development of JavaFX and the development of the ecosystem. So remember this presentation, this stack from the beginning of the presentation. We typically discuss the JavaFX platform, and there's a huge ecosystem that's leveraging this platform where libraries are created, and on top of those libraries, applications are created. It's typically those applications are created by consulting companies or employees of a company and so on. They use free or commercial libraries, and then they use the OpenGFX distribution. And it's important to mention here that Gluon provides, so the OpenGFX code base itself is mainly developed by Gluon and Oracle with lots of help from individuals and very clever developers. And Gluon provides long-term support for JavaFX 11, and we will provide we make sure that if your company wants to use a stable, mature version that's maintained, then you can use this long-term support, and then you don't have to update to every new major release. So the core of the JavaFX application itself is also supported. So this is not something that is that might go away soon. We have real long-term commitments with OpenJFX. So your investment in JavaFX, if you're an application developer, is secured. Also, this long-term support helps funding the development. This is actually how we can assign people to it and have people working on OpenJFX and paying them, which is, I think, very important for an open source project. So one of the most useful tools, and the slides will be published so you can look at the URLs later, is a Scenic View, which is a tool that I use very often for debugging JavaFX applications when there's something related to the UI that doesn't match my expectations. Then with Scenic View, you can attach Scenic View to your running application, and it will inspect the elements, and then you can see, for example, I expected some padding here, but it was null. There was no padding. How comes? So you can inspect all the properties and see live updates to the elements. So that's a real-time visual inspector, and that's available for JavaFX 8 and 11 plus. A quick note about that, as I saw there was a question about it too. There's actually JavaFX 8, and then there's JavaFX beyond 8. So the pre-modularized JavaFX is in JavaFX 8. And then when we switch to modules, some of the APIs were slightly changed. So your application, if you have a JavaFX 8 application, it might require some changes before you can run it on the JavaFX 9, 10, 11, 12, 13, 14, 15 platform. So that's why you will see for a number of those libraries that there are 2 editions, 8 and what we call 11 plus. ControlsFX, another project where we have 2 kinds of distributions, the 8-based and the 11-based. ControlsFX is also an open source project by volunteers where additional controls are created that make it easier for application developers to create shiny applications. So the JavaFX controls contain the basic information, the basic controls, sorry, but they should also be very general because it's very hard to maintain a platform that contains too many niche controls or specific site elements. But therefore, ControlsFX contains a bunch of additional controls that you can use in your application. And those are high quality. They are typically created by people that also contribute to the JavaFX controls. Then we have TilesFX from Garrett. It's just one of his projects. That's a set of widgets that contain typical tiles that you can see in that are very useful in many of the typical applications on desktop, but also, and I think especially here on embedded devices where you want to check temperature. And so all of these tiles are available in TilesFX, a very popular application. FXGL from Almas is a game engine that allows you to create JavaFX applications in Java or Kotlin on top of JavaFX, and it's making lots of progress. It's actually pretty recent, but the development is going very rapid. And I saw some 3D animations with FXGL that were very, very impressive. So if you're in game development, you definitely need to check this link because you will get a head start if you base your game on this library. Dirk Lemmerman creates a bunch of business applications and controls and libraries. For example, CalendarFX is such an application. He has open source and he has commercial applications. So there are lots of libraries available if you want to create JavaFX applications and if you want to move beyond the hello world that I demonstrated. So this is actually one of the main advantages of the Java ecosystem, that there's a huge set of libraries that you can use and reuse. And that is also the case in JavaFX. There are so many great Java developers, individuals and companies. To be honest, mainly individuals, because many companies are using JavaFX in mission critical or security intensive applications in the financial world, for example, and they don't want to. Those applications are very often not open source, or they contain some secret information, so they are typically not shared. But the foundations and the building blocks of the applications are often developed in the open source or in the wider community. Scene Builder, finally, is probably the most used tool for creating JavaFX applications. It allows you to create a user interface by simply drag and drop application controls and layouts into your page, and it generates Fxml, which integrates very well with the JavaFX application. So I will quickly show a demo of Scene Builder and how it integrates with IntelliJ IDE, unless my might be some questions first that are blocking, but I see a bunch of questions that are interesting that I will take at the end. So I will switch to the demonstration of scene builder applications now, unless Mala, do you think there are questions that I need to take now?
So Johan, there are a lot of questions. So you can just decide whether you want to answer them now or later. So first of all, is how does JavaFX compare to Swing?
Yeah. Okay. Yeah. So I will quickly answer that one. So it is, as I said in the beginning, it's sort of the successor of Swing, but and many of the people, or at least a bunch of people that were in the JavaFX team, were also in the original Swing team, and I spoke to some of them, and they it's actually the new version of Swing. If they would create Swing again now, it would be JavaFX. That's what someone from the original team told me. So it is very related, but there are some important conceptual changes. For example, JavaFX uses a retained mode, which means that we describe the user interface instead of trigger UI changes, and so it's more modern. I will, when I talk about the architecture of JavaFX, I will talk about that in more detail. So it is separate. There, the one thing that I want to mention now is that you can, in theory, mix Swing and JavaFX, because there's a Swing node in JavaFX, and you can also run JavaFX nodes in Swing. In practice, it's I personally don't recommend it because you need to take care about the threading issues.
So there's one other question I would quickly ask you, and then I would let you continue with the presentation. It is about automated testing. Is there something similar to Selenium for web available for JavaFX?
Yes, so there are a number of test frameworks, TestFX, for example, and those are indeed similar to Selenium. So TestFX is one of them. I'll make a note so that we can share the link later as well. And actually, inside the OpenJFX platform, there's a component. Well, there's a robot API that allows you, and then the testing frameworks use this API that allows you to do what, for example, Selenium is doing as well. So you can move the cursor programmatically, and so yes, that does exist, and that's an important thing.
Okay, I'll let you continue with the presentation now.
Okay, thanks. So we are going to create a new project similar to what we had before, but this time we will once again create an artifact, create a project from an archetype, sorry. And this time we are using demo with Fxml, for example. And this time we are going to use the not a simple archetype, but the JavaFX archetype Fxml. Which is more or less, apart from that, more or less the same as a simple one. But now we will have an Fxml file created for us already, and this project will by default come with two views. So it demonstrates how you can switch between views. So the project is created. Again, you see the POM file that's been created. And again, we have the, so this is similar to what I showed before. As you can see now, we have the application, which looks slightly different from what we had before. The start method, which we still override, is now very short. It is actually just a scene where we load some FXML. And the FXML here is called primary. Now let's look at the resources that we have. We can see here that we have a file called primary.fxml. And If we click on it, we see it in text form. And you see that this is some declarative thing that describes a label and a button and padding and so this is actually, and you can edit this if you prefer to really declaratively declare without any UI tool. You can do this manually, but you can also use a scene builder to edit this. There's a built-in scene builder in IntelliJ IDE, but I'm using the latest one, which you can download from the Gluon site. This is a very, very popular tool. And this has, so we actually released this version last week. And with Fxml, we can open the Fxml files that are part of our project. The only thing is I now need to remember the name. Oh yeah, that was demo with Fxml. And we have the Fxml files. It's a bit small to see probably on the screen there, but the file, let's take this primary.fxml file. There we go. What we see here is actually the declaratively declared user interface that we showed before. Or actually, I don't think I didn't run the application yet, so I'll probably do that first. So I go back to IntelliJ, and again, so this is a Maven project. It's very similar to what we had before. So we go to the Maven settings, and we look at the plugin, the JavaFX run. This one, again, will compile and run the JavaFX application. And it will show the two windows if everything goes right. So here we have the application with a primary view, and if we click on this button, then we switch to the secondary view, which just contains secondary view, and we can go back to the primary view. So that's a very simple application. But now you know that this primary view with the button to go to the secondary view is actually what that primary view contains. So if we go back to Scene Builder, we see this primary view and switch to secondary view. What we can do now, for example, is let's say, for example, add a color picker, which is one of the controls, which is completely useless in this application, but it's easy to show. So this is a control that contains a bunch of properties that you can see on the right. It's a bit small, but you can check it out yourself. For example, the value is by default white, but I can change that value to whatever. And I can change lots of other values, also layout properties. I can change them and change the width and the height, also change the behavior and integrate it with the code. I'm not going to do that now because it's if I do that, I prefer to take more time for it. So let's skip that now. I've saved this view now. And if we go back to our code, you will see that this, let me make this smaller. You will see that the Fxml is changed now. See, the color picker is there. And if we run this application again, then you will see that the change that we made to the Fxml file is shown in the application that we created. So we have, again, switched to secondary view, but here we have the color picker, which is the JavaFX control that we talked about. I will show just one more thing about this Fxml structure, and I'm getting out of time, so I will do that quickly. You see that, for example, here primary button is marked, and what IntelliJ tells us or suggests us is that we can create a field primary button. So if we click on that, a field is created in the controller, which is the Java counterpart of the Fxml file that we have here. So the Fxml file where you declaratively declare your user interface is linked to the Java file which contains the controller. How is this link realized? Well, you see that there's an in the Fxml file. If you look at the declaration, you see that there's an FX controller tag which points to org example primary controller, which is actually the class that we have here. So that is how those are linked. The linking also contains, for example, here we have an onAction tag, which might invoke a method on this class. So that is how you combine declarative development using Scene Builder with programmatic control with your Java classes. So that's Scene Builder. Going back then to the community and the role of the community in JavaFX, the unofficial homepage of JavaFX is actually OpenJFX.io. This is where I mentioned it a number of times already, but this is where you can get started with JavaFX. It contains the very basic information on how to run using Maven, Gradle, or the IDEs, and it is actually, it doesn't contain that much information, but the main point for us is that we want this to be relevant. So we want to update this whenever JavaFX is updated. So we rather have less information that's always correct and up to date instead of lots of information. So it is open. So this website is developed, is automatically created based on a GitHub repository that is open source, and we very much welcome pull requests to OpenJFX.io, and we're actually looking for people to contribute for this, but maintaining really takes lots of time. So it's not that you can simply say, hey, I have a good tip here, because what do we need to do with that advice in the next release or so? So this is really something where community involvement is important and comes with responsibility. So about the community and the product names, JavaFX and OpenJFX are often used in a mixed way, and JavaFX is what I think, at least the way that I explain it, is JavaFX is a product and OpenJFX is a code and the project where JavaFX is being developed, and that's the OpenJDK project hosted on GitHub with GPL and class path exception as similar to the OpenJDK. There was a question about isn't JavaFX too tightly coupled to Gluon? I'm actually flattered by that. But I don't think so. It's just that Gluon is, together with Oracle, the main contributor to OpenJFX. And we, so Kevin from Oracle and myself are the project leads. We follow the same strategy as the OpenJDK, where everyone can contribute. And if you follow the rules, where you can first create an issue, then create a pull request. It's being discussed. It can be discussed on the mailing list, and then it's integrated. So it's very much developed in the open. Gluon also releases builds, the distributions, but that's totally done on this open source code. So others can build it as well. I think we contribute a lot. So I think we have some knowledge that well, you only get by contributing, but that's it's not that Gluon owns JavaFX. So we do create the builds, and we follow the same release cadence as the Java SDK. We are now at 15.01, 15.02 will be out soon. Then we have 16. We typically release in the same week as Java. And we also have, similar to the Java SDKs, 3 types of builds. So the regular builds, 15, now 15.01. I actually don't recommend those. The early access builds that we are doing are more important to developers. For example, 16 EA6, I think, is the latest version. This is not just some experimental version. This is really what goes in production soon, because the quality bar of any OpenJDK project is pretty high, so nothing comes in an early access release unless it followed the same procedures as the OpenJDK project. So that is what I recommend developers to use. And then the long-term supported builds is what I recommend companies to use if they want to have stability and security. So that is what we distribute to our JavaFX 11 LTS customers. So the government, I think I covered that already, so no need to talk about that soon. Then I will very briefly go over the structure of the JavaFX platform, but I will skip most of this because I think I prefer to spend more time in showing how to get started in IDE instead of talking about the structure of JavaFX itself. So the JavaFX platform contains the JavaFX APIs on the top, and at the bottom it integrates with the low-level rendering and the low-level windowing system of the operating system. And the link between those is done by the internal implementations. So typically the top API, the JavaFX APIs, that's all that developers see. But and this is actually so the stage with the scene and the nodes. So for example, every control is a bunch of nodes, and that is the scene graph based model that we have here. Here we see actually the answer to how is JavaFX different from Swing. JavaFX is using retained mode, so the developer declares the state of the node. He says, for example, this needs 20 pixels padding, and then the rendering pipeline will look into the specifications and will do the rendering. So that's actually a separate system. So those are two different components of the system. So the rendering will use platform-dependent optimization when possible, and will fall back to software if needed. And there are pipelines for different desktop systems, mobile and embedded systems. Finally, and this is the last part of the presentation, it's about the future. We learned a lot over the past 25 years in Java. And one of the things that have evolved is the mobile landscape. Java was originally designed for mobile and embedded, but it was a very hard market to get in these days, because it was hard to bundle the Java runtime with mobile devices or embedded devices, because the manufacturers want to have control about the device. And today we have app stores. And the concept of the app store is something that's interesting, not only for mobile, but also for embedded and desktop. And native applications for the mobile devices, they bundle everything that is needed. And that is something that we can do with Java as well on the desktop. The biggest hurdle that we heard from users in the past was about Java on the desktop was, I do need to update this Java, whatever thing it is, every way too often. And it's annoying. Actually, one of the times that I traveled to the US for Java 1, at the border, the officer asked me, what are you going to do? And I said, I'm going for a conference about Java. And he became a bit angry with me. And he said, Java, that's this thing that I don't know what it is for, but I have to update my computer so often for it. So that was really a showstopper for many users. This is already now sort of fixed. If you use JLink in Java Packager, you can bundle your application with a runtime. But we are going one step further now, and we compile the JavaFX application with all the dependencies ahead of time. And this is something that it's nice on desktop, but it's actually a requirement on iOS. We cannot have a JIT compiler on iOS, so we need pre-compiled code on iOS. So how do we do this? We compile the Java bytecode, including the JavaFX bytecode, to native code ahead of time. And the native code that's needed for the hardware-accelerated rendering, but also for the Java core libraries, are compiled to the specific target as well. And this is where we're using CrallVM native image, which allows you to compile your Java application into native code. And the Java runtime itself is also compiled into native code. So all the functionality that your Java application needs, threading and so, is compiled to native code. And the native libs come from OpenJDK mobile. So this then leads to this architecture where we have Gluon Substrate, which is a plugin or which is invoked by a plugin that Gluon distributes as well. It's again open source. And this one translates your Java application, JavaFX application, all the dependencies that you have with CalVM native image. It will include the SDK required for the target. It will include the JavaFX SDK, and it will make sure that if you want to have the Gluon commercial add-ons for creating nice, shiny applications, and so, or access to the device-specific functionality, it will include those as well. And then you can create applications you can have native applications that run on desktop, on mobile, or embedded. And you can even use GitHub Actions that automate this for you. And the first examples are now, I'm seeing reports from people that are using this to create applications and upload them to the App Store and the Play Store. So this is actually, I think, very exciting. And this is what I think the future of Java on the client is very, very bright. And it goes, of course, desktop. It's very important to have desktop, but also to any other client platform. So in summary, JavaFX provides the UI platform and the APIs for Java, leveraging all of the good things that we know from Java. And it allows these applications to be deployed to desktop, mobile, and embedded. There's a huge ecosystem, and it's developed in an open development model, the OpenJFX repository, and it allows you to create native applications on desktop, mobile, and embedded devices. So I think that's my presentation. I'm looking at the questions now, and unless Mala, if you think there's something that I really should answer, I will quickly go over them and choose an order.
Yeah, so first of all, thank you so much, Johan. It was amazing. I loved the screenshots that you had where you are using JavaFX to create the applications, especially the ones which is being used by NASA. So there were multiple questions regarding working with JavaFX with different versions of Java with different build tools like Gradle, Maven, and I think we have covered most of them. We also mentioned the link to javafx.io, which has the steps to go on with creating applications with those combinations. So I think we are done with that part. One question that has been repeatedly asked is the support of JavaFX in Android Studio.
Yes, so those are two different things. If you want to create a Java application in for Android, you don't use Android Studio, you use your Java IDE. You can use IntelliJ IDE, or you can use NetBeans or Eclipse. Because if you're creating an Android application, and it might be confusing because when we started doing mobile development, we were using the Android Java virtual machine. But now that we are using CalVM, we are not using the Android Java. We're using the real Java, so the OpenJDK Java. So it is it is very different from creating an Android application. It might be possible to do it, but what what our tools are doing, and actually it's just Maven and Gradle extensions, so you invoke those in your IDE. What those are doing is invoking the same commands that Android Studio would invoke under the hood to create an APK out of your application. So it is using the command line, the same command lines as Android Studio is doing, but it's not doing. It's a different IDE actually.
Okay, the next question, I'm not sure whether you answered this question. This is the plan for supporting embedded clients with hardware acceleration. Right now, the rendering pipeline using OpenGL ES2 through, I think you answered that. Did you?
Yes, no, I didn't answer that, but it's actually a very good question. So depending on the embedded devices, there are different types of GPUs and different types of graphical drivers. So what we make sure is that the software rendering is working on all systems, because that is not dependent on the GPU. But we also have a bunch of builds for embedded systems. For example, the Raspberry Pi 3, the Raspberry Pi 4, 32-bit, 64-bit with Ubuntu, with Raspbian, where we have hardware-accelerated rendering, and that's amazing. I see the performance really boosting, but those are not generic. If we have, for example, JavaFX for macOS, that works on all macOS systems, of course. But for embedded, we're using DRM for the hardware acceleration on the Raspberry Pi, which is getting more standardized. So and there. It's actually based on customer demand. So we have a few things like that we always support, like the Raspberry Pi, but then companies come to us with a specific device with specific UI driver, and then we leverage that UI driver to benefit from the hardware acceleration.
There's another question, which is there a plan to integrate EGL with Prism ES2?
Yes, and that's actually so what it's in the code base since a month or so, so it will be part of 16, where we have Monocle, which is one of the rendering pipelines, which has an EGL front end, so front end or binding. And that is the thing that we use to bind the JavaFX rendering pipeline with the DRM kernel system using EGL. So EGL is one of the supported sub-platforms of Monocle. So that is integrated in the sense that those things are actually next to each other. So Prism ES2 is used on Mac, Linux, and some of the embedded devices. And on the embedded devices, EGL is one of the things that is supported there.
Of course, thank you so much. A lot of viewers are comparing JavaFX, Swing, and Electron. So one of the question is the resource usage of JavaFX application compared to Swing or Electron. A similar question is embedded Swing into JavaFX. Does that causes an issue with rendering? And third one, again, a related question is JavaFX is really hope for today's desktop. Gluon doing great work to support it. What is memory footprint in comparison with Electron and Qt56?
Yeah, those are very good questions. And I think at this moment, we, or at least before, let's say until a year ago, we had the overhead of the JVM. And that adds to the footprint. And that is, that makes a Java application typically heavier than a real native application. But what we're seeing now is, now that we're using GraalVM native image to aggressively compile the application and all its dependencies into a native application, we see that the footprint decreases drastically, and performance, especially startup, increases a lot. So I don't have official benchmarks yet, and it's of course difficult to compare a JavaFX application and an Electron application, but I'm convinced that we're doing much better there, especially thanks to GraalVM native image. So the resources that are now used by JavaFX and the memory consumption at runtime is much lower than it used to be, and it's actually one of the killer differentiators of JavaFX in combination with GraalVM native image.
Right. The other one is it's about does JavaFX use hardware acceleration on rendering?
Yes, so that is it is whenever what I said. Whenever it's possible to use hardware accelerated rendering, JavaFX will use hardware accelerated rendering. If it is not possible, for example, we do some checks if there's a broken GPU or a not supported driver on your system. JavaFX will fall back to software rendering, but it's by default used. It's by default using JavaFX.
Okay, so I'm not following this question. Sorry, I'm not following the releases of JavaFX, so I'm unsure whether what is the answer to this question. So viewer asked that I noticed that since Java JDK 8, which was released sometime in 2013, no, it was 2014, no new features have been added to JavaFX, unlike the core Java language. So when can they see more features coming to JavaFX?
Yes, so the question about the roadmap is something that we often get, and I do know that if well, one of the things that are often asked is, can you create an HTML text editor, for example? But the thing is, it's not good marketing for me, but we don't want JavaFX to be the most shiny library. We want this to be useful for library developers and application developers. So new features by, for example, new controls, that is something that you make the platform more heavy, and it needs to be maintained. So if there are really new features, we rather look at support for new pipelines. For example, there will be support for Metal coming soon in JavaFX, and we make sure that we keep supporting new versions of operating systems. And so new features is nice if there's really the need for a new feature, and then we will do it. But it's not that we want to have a contest with other with other frameworks where we want to have as much new features as possible. If you look at the list of issues that are fixed in every JavaFX release, I think it's pretty impressive. And we rather work on stability than on adding new features. I also think that, for example, the integration with GraalVM native image and boosting the performance there is more important than new features, which are actually typically created in community projects like ControlsFX, for example, or the game engine. And so those are really cool features, and they are available. And what we typically do also in JavaFX is we let them incubate a while in third-party frameworks, and when they're very good and when everyone agrees this should be in the core, then we can integrate them in the core. But it's we really focus on the quality first.
Right. So, Johan, we are running out of time. We have a lot of questions, but I'll take just the last question. So one of the viewers mentioned that you mentioned while you were presenting that, no, I think that was on Twitter, that a new product that will come out. So is that related to JavaFX?
Yes.
So that's a short answer.
That's all I can say for now, yes. But it is related to JavaFX, yes.
Okay, so I would recommend the one who asked the questions to follow Johan on Twitter if you are already not doing that, so that you get more updates when the product is out. Probably Johan doesn't want to talk about it now.
And follow Gluon on Twitter, of course, Gluon HQ.
Yeah. Yes. So thank you, Johan. That I learned a lot from today's session. Thank you so much. And if you want to have any closing remarks.
No, well, thank you very much for organizing this. I really appreciated that, and I'm really glad that I could do this. And I hope that there are many people now knowing that they can use IntelliJ IDE to create shiny Java applications for desktop, mobile, and embedded.
Thank you so much. Thanks everyone for asking the questions and for attending the session. And do keep an eye on the next set of webinars, live streams that we have planned for IntelliJ IDEA. The next one is on 10th of February, which would be using Maven with IntelliJ IDEA. So thanks again, and bye everyone.